I wanted to write a second Python program. It's a second Python program on the free-for law to illustrate packages, modules, and functions. So often we want in physics problems to do operations to use functions that are beyond the simple addition, subtraction, multiplication, division, arithmetic operations we met in the last example. So Python has associated, is accompanying it, a number of packages. There's a package NumPy. There's a package SciPy. And these packages include lots and lots of useful functions for physics programming work. For example, the natural logarithm. For example, exponential. For example, trigonometric functions. For example, the square root function. And so this second example of the free-for law, in which rather than calculating the distance fallen in a certain time of a falling body, I'm going to calculate the time taken to fall a certain distance for a falling body. I'm going to use these Python packages. Specifically, I'm going to use the NumPy package as an example of Python packages. Before I actually write the code, before I write the free-for code, let me just write a few statements in our Jupyter Notebook to show you, how to access, how to use functions in these packages. This statement, from numpy import log. This statement imports the log function, imports the natural log function from the numpy package. So this is how you tell Python to import a particular function from a particular package, from numpy import log. And so we can execute that statement. Now, if I instruct the code to calculate the logarithm of a particular number, log 2.5, and execute that statement, it gives me the logarithm of 0.92. So that's an example of using a function that's available in a particular package. Let me give you another example. So this statement, from numpy import pi, imports the constant pi, 3.14, from the numpy package. Let's execute that. And then if I give the instruction pi, it will print out the value, the numerical value of the variable pi. So that's examples of how to access functions, how to access constants in the example of the NumPy library. In general, when we import functions from libraries, packages, like we imported log and pi from NumPy, those import statements are at the beginning of the code. It's good practice to put them at the beginning of the code. And generally in Python, we always put them at the beginning of the code. That in function log, that's an example of a function in Python, but we've actually already met other examples of functions in Python. The input and print statements for input and output are inbuilt functions in the Python language. So those are also examples of functions in Python. Now, often in a computer program, often in a Python program, you don't just want one function, or you just don't want, one constant from a library, from a package. You might want multiple functions from a package. You might want multiple constants from a library. In that case, of wanting to import many functions or many constants, there's other ways we often import those functions and constants. And so let me show you a couple of examples, a couple of illustrations of other ways to import constants, import functions. So from NumPy, import asterisk. That imports every function and constant in the NumPy package. Compare it with from NumPy, import log, which just imported the log function from the NumPy package. So if I execute this statement, we import all the functions, all the constants in NumPy. And again, I could calculate the logarithm of 2.5 to be 9.2 using one of those imported functions. A second way to import all the functions and all the constants in the NumPy library is to actually import the package, NumPy package, into your code, rather than import this individual functions and constants into your code. Let me show you what I mean by this. So import NumPy as MP. What that does is import the package NumPy into your code with a alias or a name NP. That's distinct from last example where we imported all the functions and constants, the log, the sine, the square root, from NumPy into our code. Now, in this case, if we were just to type log 2.5 and evaluate that, we would get an error. This is an error message. This is an error message that's saying it doesn't recognize log. In this case, we have to tell the Python code, we have to tell it that that function is located in this package that we gave the alias, or we gave the name NP. Now, if I evaluate this statement with this syntax, note the period here between the alias name of the package and the function that we want, it evaluates the natural logarithm of 2.5. Now, I've shown you two ways of importing the functions in NumPy. This second way of importing the function is a little more complex. You've got to use the alias name when accessing the log function or any other functions. The first way is a little more simple. You don't need to use the alias name when accessing the functions. But the first method has a problem that the second method doesn't have. If you're importing multiple packages, you can get conflicts between names of functions in different packages. And the second method of importing the package with an alias or a name avoids those problems with conflicts between same named functions in different packages. So I think this second way of importing the package rather than importing the functions is a better way of doing the importing. One final remark about these packages and importing functions and importing packages is that some packages are very big packages containing lots of functions. NumPy is a very big package containing lots of functions. SciPy is another really big package containing lots of functions. In those packages, the packages are actually subdivided into modules. And then within those modules are functions. So a particular module contains a group collection of related functions, like the particular package contains a group or collection of related modules. Think of this like maybe, you know, the package being a city, the modules being the streets in the city, and the functions being the homes on the street. Or this is maybe a better example. I think this is a much better example. Think of this like the package is like a library, and the modules are like the bookshelves, and the books are the functions. Now, the way we access a module within a package rather than the entire package is as follows. Let me just show you a couple of examples. So this line imports not the entire NumPy library, but it imports the linear algebra module within the NumPy package. And it imports it with an alias that is just linalg. This line imports from the SciPy package the module stats, the statistical module, and it imports that as an alias, gives it a name that is, in this case, is just stats. So in this code now, we have accessible to us a particular module from NumPy, the linear algebra module, and we've given it an alias, and we have a particular module from SciPy. It's the statistical module, and we've given that an alias. And so we can, in the case of large packages with modules, refer to the modules via this syntax of the package name, period, the module name. So now I'm going to write my code. I'm going to write my Python code to calculate, using the free for law, the time it takes an object to fall a certain distance. I'm going to ask the user to specify the distance, and I'm going to calculate the time taken. And I'm going to use the square root function from the NumPy library. So the first thing I'm going to do is import the NumPy package with an alias np. And so at this point, my program will be able to use any of the functions, any of the constants within the NumPy package or NumPy library, remembering that we would have to refer to those functions, tell the program that those functions are in the NumPy package that we've aliased as np. As in the previous code, I'm going to need the acceleration of gravity. So let me set the variable G to be the float 9.8, execute that. Remember, that's just assigning this variable G to this floating point variable, floating point number of 9.8. Then I'm going to read in input from the user, so input from me. This time is the distance fallen in meters. I'm going to read that into my code. And I'm going to remember that the input function imports a string, and I want to turn that string into a floating point number for my distance fallen. So let me execute that. At this point, it's going to ask me the distance fallen. So let's try 30 meters. And that's assigned the quantity, the variable y, to 30 meters. Now I'm going to calculate the time that it took to fall that 30 meters. So I'm going to call the time variable, I'm going to call that t. And according to the free fall law, then the time taken to fall a certain distance is the square root of twice the distance fallen divided by the acceleration of gravity. So I'm going to feed in that result, program that result from the free fall law. So the square root of 2 times the distance fallen, that's the variable y, divided by the acceleration of gravity, that's the variable g. And then execute that. Now, notice in that statement that when I refer to the square root, I had to take the square root, which is a numpy function. I had to tell the Python code that that square root function was in the numpy package, that I'd alias to MP with this syntax here. In front of the square root function, I put the alias name of the package. Anyway, this is again an assignment statement that assigns the new variable time to be the result of this calculation on the right-hand side. And finally, I can print out with the output statement, the print statement, what that time is. So let me print t. And we find it's just under 2.5 seconds. And so this is an example of a second free fall law calculation. Rather than calculating the distance fallen in a certain time, here we're calculating the time taken to fall a certain distance. It involved arithmetic calculation, it involved input output, but this one also involved the use of packages in Python and how we use packages in Python. And I actually showed you several ways of importing packages, importing functions within packages, importing modules within packages.